Okay, this is Mr. Ng again. I'm reshooting question 4 because I think the audio quality in the last video wasn't very good. Okay, so a tank traveling at a uniform speed of 30 meters per second across a straight road past stationary car immediately begins to move with uniform acceleration of this in the same direction as the tank, right? So when the tank passes the car immediately starts moving, right? Calculate the time taken for the car to acquire the same speed as the tank, right? For questions generally in kinematics, in case you find it very difficult, then they give you a lot of information. Most of the time, the best way to solve is just draw VT graph, right? So here I will draw a VT graph, right? Okay, they already said that the tank got uniform speed of 30, right? So the tank forever move at this speed is 30. Alright, this is the tank. Right, then the car start from 0 because begins to move. Let me start from rest lah. Right, with acceleration of 2 meters per second square. So something like that, the car like that move. Alright, calculate the time taken for a car to acquire the same speed as the tank. So when does the car hit 30 meters per second? Because the tank never ever change speed, right? That's what the question is asking for, right? So this is the point where they are interested in. What is the t? Alright, so I know the gradient of a velocity time graph is the acceleration, and I know the acceleration is 2, right? So I can just use a equal b minus u over t, right? Right, t is the point in question that I want, right? My a is 2, right? So it's 2 equals to v, which is 30, right? My car need to acquire this speed. Initial speed of the car is 0. The time taken is the question mark, right? So the time taken for the car to do this is 15 seconds, right? That's the answer to part A, right? Time taken for the car to catch up with the tank, right? So what you need to do is understand what's happening in this period. Remember that once the tank passes the car immediately starts moving, right? So this is the point. This point is where they both are at the same starting location at t equals 0, right? But at t equals 0, you realize that the tank is actually moving faster than the car, right? You see the car speed is 0, the tank speed is 30. The car's speed is some value a bit higher lah. Maybe this is 10 I don't know. But the tank speed is 30. Then the car speed is 20, the tank speed is 30 still. The only time where they become the same is here, right? Car speed is 30, tank speed is 30. But in this duration, right, you can see the car keep falling behind the tank, right, in this region, from here to here. How much does the car fall behind the tank? We can calculate through area under graph, right? Remember the VT graph is useful for two things, alright? One, to calculate gradient using the to calculate gradient so that we can find acceleration, and secondly, the area under graph gives us displacement, right? So if I look at the car, right, if I call this distance the car travel, or this displacement the car travel A, right? Because the area under graph I call it A. So if the car and the tank were here, the car travel A. How much does the tank travel after 15 seconds? Can you see that the tank travels this rectangle, which is double the car, which is a triangle, right? Can you see the tank cover this extra amount, blank here that I didn't shade, right? So if the car cover A, can I say the tank cover 2A? Correct or not? It's not an unfair statement to make, right? Correct? Because this part is also A, right? Right? So now this is the tank, right? This is the tank and this is the car, right? And this is 15 seconds. When can the car catch up with the tank? The car is behind by A, right? So I need to find the area whereby a time whereby the car covers area of A, alright, more than tank. So but luckily after this time t 15 seconds, right, the car is actually starting to catch up with the, let's say, tank already, right? So you look at, let's say, this arbitrary time here, which is, let's say, let me call this x, right? Let's this time x, right? You realize that the car travels this trapezium. Can you see this trapezium, right? Then the tank travels this rectangle lah, right? So the car travels this triangle more than the tank. Can you see that? Because the car travels this trapezium, can you see the trapezium? The tank travels this rectangle. So what's the difference? Now the car is winning the tank by this area, right? Can you see this shaded area? This is how much the car is winning the tank after they become the same speed, which is here, right? So the question when the car take over, when does the car catch up with the tank, is when this area here, right? When this area here that I just shaded, this triangular area here become equal to this area, right? Right, because this is the lagging, this is the gap that the car has with the tank. So if the car can cover an area that is equal A here, isn't it that the car catch up with the tank? Right? So when does that happen? If you look at this line over here, right, this line is a straight line. So if this is 15, let's say this is 15, right? When would a triangle here be equal to a triangle here? Can you see is when this is 15 also? Alright, okay, hopefully you can see that. Alright, then once you can see that, it becomes easy, right? When this becomes 15, you realize that, hey, this triangle over here, which is the distance the car cover more than the tank after they become the same speed, is equal to the distance that the tank cover more than the car before they approach the same speed. Alright, can? So that's the answer. Actually, the time taken for the car to catch up with the tank is 15 plus 15, right? Which is 30. Okay, so it's just seeing shapes only. I don't want you to do advanced maths for physics. Alright, you can see that our supposed mathematical tricks all look like that. Alright, so don't be too overtly concerned with these kind of things. You ask your teacher to help you see if you cannot see. Okay, but don't get too stressed by the mathematics behind physics. Okay, it's not the core component. Okay, normally this type of question is 1 mark MCQ. Yeah, but we put here to make sure that even that 1 mark MCQ in the O level you can get, but you don't overly stress yourself over the mathematics. Okay, Ken? Right, distance traveled by the car where it's level with the tank. This one you can just do a calculation for area under graph. Right, so you either calculate this area over here, this whole triangle, right, knowing that this is 30, or you can calculate this rectangle with the tank. Okay, you can refer to the answer in the PDF that I sent you via email.